Hi everyone, Mr. Jolliffe here for your Tuesday notes, and today we're going to be talking about another method for solving systems of linear equation. So far we've talked about two methods, solving by graphing and solving using the equal values method. We learned that solving by graphing is best when both of your equations are written in slope-intercept form, and that solving with equal values method is also best when things are both written in slope-intercept form. Today's method, solving by substitution, works best when one equation is in slope-intercept form and the other is in standard form. So a reminder, slope-intercept form is y equals mx plus b, and standard form is ax plus by equals b. So we want one equation that has been solved for x or y, and one equation that has the x's and y's together on the same side. So a couple of examples are first, y equals x minus 2 and 3x minus 2y equals 6. That first equation is in slope-intercept form. We have y equals mx plus b, where m is 1 and b is -2. The second equation is in standard form. Ax plus by is c, where a is 3, b is -2, and c is 6. So this is a perfect candidate for solving by substitution. Our next two examples are also good candidates for solving by substitution, but you'll notice those first equations are not in slope-intercept form. For this equation set boxed in yellow, our first equation is x equals 5y. That's definitely not slope-intercept form, but x is by itself on the left. So that makes this a good candidate. The equation boxed in blue over here is very similar. We have y equals 12, or y equals a constant. Not technically slope-intercept form, but because we have y by itself on the left, it's a good candidate. Let's talk briefly about our step list for solving by substitution, and then we'll do two examples together. When solving by substitution, our first step is to choose the equation that is solved for x or y and substitute that expression into the other equation. So step one is the substitution step. We choose the equation that's already been solved for one of the variables. We take the right-hand side of that equation and substitute it into the other equation. This should give us an expression that only has one variable in it, all x's or all y's. Once we've done that, our second step is to solve the resulting equation. So this is going to involve using those skills that we learned back in modules 3 and 4. Distributing, grouping like terms, the addition property, the multiplication property, the division property. You should show each step in this solving process. Make sure you're writing it down. At the end of step 2, you should now have a value for one of the variables. Step 3 is to take that answer and substitute it into the first equation to solve for the other variable. So step 2 gives us the first half of our solution. Step 3 gives us the second half of our solution. You should write your solution as an ordered pair, x comma y, just like we practiced last week. We always want to write that point of intersection as a set of coordinates or an ordered pair. Let's go ahead and practice that with two examples. So our first example, we have y equals x plus 8 and 5x plus 2y equals 9. Here, the first equation is in slope-intercept form. Y equals mx plus b, where m is 1 and b is 8. So this is a great candidate for solving by substitution. And to solve by substitution, what we want to do is we want to take the expression on the right side of the first equation and substitute. Everywhere we see a y, we're going to replace it with x plus 8. So in the second equation, here's a y. I'm going to replace that y with x plus 8. That's the very first step of this substitution method. So let's see what that looks like. For step 1, when I make that substitution, we get 5x plus 2 times x plus 8 equals 9. Our second step is to take this equation that now only has x's in it and solve for x. When I look at that equation, the very first thing that I see is I see parentheses. And we learned that in order to undo parentheses, we have to distribute. So I'm going to multiply everything in that parentheses by 2. 2 times x, 2 times 8. When we do that, we have 5x plus, and then 2 times x is 2x, and 2 times 8 is 16, and all of that equals 9. Focusing on the side with variables, the next thing that I see are 2 like terms. 5x and 2x, they both have an x in them. We need to combine those like terms before we can start moving stuff from one side to the other on the equation. So 5 plus 2, that's going to give me 7 x's plus 16 equals 9. At this stage, this is a 2-step equation. We undo the addition or subtraction, and then we multiply or divide by that coefficient to move it. So first, we're going to undo that addition by subtracting 16 from both sides. On the left, those 16s are going to cancel, and that's going to leave me with 7x. On the right, 9 minus 16 is minus 7. Last step, we have to deal with that coefficient, which is being multiplied by the x. And undoing multiplication requires division. So I'm dividing both sides by that coefficient of 7. On the left, it cancels, and all we're left with is x. On the right, minus 7 divided by 7 is minus 1. So we've found the first value in our solution. We know these two equations, if we graph them, will cross at x equals 1. Now we need to find the y value that goes with it. What's the height where they cross? To do that, step 3 says take that first equation, y equals x plus 8, and substitute in our answer from step 2. Meaning in that first equation, everywhere I see an x, I'm going to replace it with minus 1. So that's going to give us y equals minus 1 plus 8, or y equals 7. So now we have both pieces of our solution, both coordinates for that point of intersection. So I'm going to write our solution down here at the bottom. Our solution is x comma y, so minus 1 comma 7. That's where those lines should cross. I want to check that. So we're going to graph these lines. So give me just a second, and I'm going to do what I saw some of you guys doing with the homework last week, which was pulling up GeoGebra or Desmos to check your answer, which is awesome. So I'm going to do that if you'll give me just a second here. So hopefully you can now see my GeoGebra screen. I'm going to rewrite that solution really quick. We know that our solution was minus 1 comma 7, and that's what we want to check. So we're going to graph these two equations really quick. First one is y equals x plus 8, and then 5x plus 2y equals 9. And you can see they're crossing in the upper right-hand corner. I'm just going to drag this to recenter it. And when I click that point, I can see those intersect values are -1, 7. So we did this problem correctly, which is great news. Let's go ahead and try another one. So let me clear the solution here, and we're going to move on to example 2. So example 2, we have x equals -2y plus 6, and 2x minus 3y equals 26. Just like last time, we know that our first step is the substitution step. So I'm going to go to that first equation. I'm going to take that expression on the right, and in the second equation, everywhere I see an x, I'm going to replace it with that expression. So let's take a look at what that looks like. For step 1, our new equation becomes 2 times, and then in parentheses, -2y plus 6 minus 3y equals 26. And we can see the only difference is that x has been replaced by the expression from that first equation. Second step is to solve that equation for y. Solve it for the variable that's left. So just like last time, we're going to follow those same steps in order. First, we need to distribute, group like terms, add or subtract, and then multiply or divide. Most substitution problems are going to follow those steps in order. Occasionally, you'll have fewer steps if the equation is simplified. But in this case, we do need to distribute. 2 times -2y is going to give us -4y. And 2 times +6 is +12. And then I just copy down the rest of that equation. -3y equals 26. Just like last time, second thing, I search for like terms. And I see a term with a y and a term with a y. I know I can group those together. So -4y and -3y is going to give me -7y. And then I copy down the remainder. +12 equals 26. This is the add or subtract stage. I need to undo this addition by 12. So I'm going to subtract that from both sides. And when I do that on the left, those 12s cancel, giving us -7y equals, and then 26 minus 12 is 14. Last step in our solving, we need to get rid of that coefficient in front of the y. It's being multiplied, so we're going to divide by -7. Divide by that coefficient. The -7s on the left cancel, and we get y equals -2. So we know our equations, when we graph them, are going to cross at a height of -2. Now we need to move on to step 3 and find the x-coordinate that goes with it. Remember that step 3 goes back to that first equation. X equals -2y plus 6. And everywhere we see a y, we're going to replace it with our answer from step 2. So this y is going to become a -2. So x equals -2 times -2 plus 6. We have to do multiplication first. 2 negatives make a positive, and 2 times 2 is 4. So we get 4 plus 6, which is 10. So that's the second piece of our coordinate pair. We now know that these two lines should cross at 10, -2, x, comma, y. I'm going to repeat the process that we used for that last problem. We always want to check our work. So I'm going to pull up GeoGebra again. Give me just a second to find that window. Looks like everybody can still see GeoGebra, which is good news. And let me erase some of that writing and delete those lines from the last example. Clean up our screen here. Okay. So last example, delete, delete. New equations, we have x equals negative 2y plus 6. And we have 2x minus 3y equals 26. And you'll notice I can't even see equation 2. So let's move our window over. I'm going to click on that point of intersection and 10, negative 2. So we did, in fact, do that correctly. Okay, so let's pull up that writing again, just to remind you of what your solution should look like. You have the rest of the period to work on the activity for today, which is practicing solving by substitution. Please remember that you should be showing all of this work. I should see all 3 steps on your paper, and I should show those intermediate steps where you're solving those equations. Also, if you get stuck or you want to check your work, you have a couple resources. You should be checking in with your neighbors to check that your answers match. And you can use your computer or your Chromebook to use GeoGebra and graph those lines to check your work. Again, you won't get credit if you don't show this intermediate stuff. So make sure that in addition to using GeoGebra to check, you're also going through this substitution process. If you have any questions, you can reach me via email. Otherwise, I will see you on block day.